Okay, thermally broken exterior wall assemblies and party walls. We're pretty proud of what we have, and I won't ever mention our name of our product from here on out, but everybody can kind of figure out who we are. I'm pretty impressed with the number of people that you have on, Brett, that want to listen to us chat about how to make wall assemblies, foundation assemblies, roof assemblies, you name it, more energy efficient, and for that I'm thankful. So I'm the inventor. I get to chit chat about this stuff all the time. Mark Willie is one of the founders of Passive House in Chicago, and he is our educational guy that we try to get out in front, and not me. I'm going to go behind the scenes here. So okay, so here, let's get going. Okay, so first off, Minnesota, we're proud to be part of this project. They asked us for our uninsulated, thermally broken wall studs, and so we filled them the whole house, and they ended up being able to get this result. They're one of the winners of the DOE's Net Zero Award. They got some crazy results, all packed into 5.5 inches, and so 4,795 square feet. They ended up with a HERS score of -8. Air changes per hour 0.15, and so I don't really know what all that they did besides they used us. They used 5.5 inches of I won't rattle off the brand name of foam, but it's a HFO blowing agent, not HFC. So hopefully everybody online knows the differences between the two. It's quite impressive. So annual savings of $5,900. It doesn't take very long to pay for all of their upgrades that they did in order to make this energy efficient house. It's a huge testament to. I'm not going to say it's just the T-stud, because there I rattled off the name. It's not just a testament to us and the thermally broken wall stud, but it's a testament to every builder, every architect that's out there that's trying to get to this level. And there's little tips and tricks that we're going to give you along the way that'll help you get there. So we're just one piece. Okay, so how did this, well, I can't say how it all started, but this right here is actually my hot tub in the back of my house. And so the one interesting thing about a hot tub is they put a minimum of 2.5 inches of foam on the outside edge and up to 4 inches thick in the middle, because obviously they need to stop that heat from coming through. Otherwise, your hot tub in the winter, obviously we got 8 inches of snow in Minnesota today. Yeah, you have to have it. You have to have a thermal break. This is a perfect example of what the benefit is of a thermal break through an entire wall assembly. It's not just the wall, it's the rim, it's the foundation, it is the floor, and it's through the roof. You got to do whatever it takes in order to seal that up airtight. If you control the air, you control the destiny of that house. And the one thing you can't control, so I'll get my humor in here, is you can't control how many geriatric dogs or cats go in and out the door every day. Okay, so if somebody created a computer program that was absolutely perfect, it doesn't, it's just, there's some things that you can't control. Okay, San Antonio, Texas, same deal. The payback for our product is obviously half the time in San Antonio than it is in Minnesota, because the cost to air condition with electricity is twice the BTU of what it is with natural gas in the north. All right, next. I don't want to say it, but this is actually my house, built in 1989. Yeah, I bought it 4 years ago, but this is a classic example of heat loss, and this is just, it's a disgusting photo. I'm ashamed to say it's mine, but it is mine. We've looked at using another product that we have coming up to strip the whole outside in order to make this whole entire house blue. But it's a good remodeling undertaking that we're going to be taking on at some point here. So here, this is the perfect example of what you want. So this is the very first prototype that we built. The swing in temperature is 40 degrees, and we were able to get blue throughout the whole thing. So we have our insulated wall stud. We used a blown-in blanket in here. We actually used blown-in fiberglass in all the walls, the ceiling. We used polyiso in the entire floor, and then you can obviously see the red and the yellow where all of the heat loss is. Couldn't control that, but I think it's a pretty good looking shed, if I don't say so myself. Okay, continuous. How do you make that continuous insulation that everybody talks about? Thermal bridge on the left, typical 2x material sitting in the middle there on that left. We did throw an R5 or an R6 continuous insulation on the outside of it, and you still get heat loss or heat gain through that stud. That 1 inch that you put on the outside, it is extremely effective, but it only makes that stud have an R value of probably 11. Versus over on the right-hand side is our thermally broken stud. The stud itself is 19, is what it's been certified for. And obviously through that wall assembly, it's more like 22. So our goal was to make the whole entire wall assembly, including the framing members, have the same R value as the cavity insulation. So our goal was to make your car run on 8 cylinders versus the typical wall assembly. If you run all the math, all your framing is you're only running at 3 cylinders, so you have a huge loss. So here's our 2 variations that we have. The one on the left is a foamed in one. We have the frame on the far left is similar to the frame that's on the far right, but this is a foamed in product. R value certified at over 19, but we use the HFO blowing agent in that foam. And then on the right, so the wall assembly on the left, if you're using that product, we started out thinking that this was going to be for everybody who used bad insulation. So 58% of everybody uses that bat. On the right, this is 38% of everybody uses a blown in or a spray in product. And so we made the bare naked version of our product in order to be able to accommodate those people. And if you look at the top, one of those wood members is perpendicular in the unfoamed version, and the other one is too. So we're actually certified because we stopped the ability of the board to deflect in that x-axis. We stopped the ability of the board to deflect, so we're certified to hold actually 8,600 pounds. Not that you can use that, but unless you're putting that stud on concrete or steel, but that's how strong we made it. Okay, HERS score. So we've had some challenges with HERS score ratings, with energy efficiency, trying to work with certain companies. I'm not going to ever pick on ResNet, they're super people. But they did confirm the 2.5 inches of insulation thermal breakthrough a wall assembly isn't really registering that well. Almost all of the modelers come up with a 24% reduction in the heating bill across the country. And the air conditioning, for some reason, shows up as a +5. And we know that that's not true. So there's, as technology increases with these modelers, I'm a certified energy auditor, so I do all of my modeling by longhand and calculate it out right to the square inch. I can't leave a square inch undone. But when we first did American Residential Building Science in Minnesota, what they did is they packed all the studs off to one side, and then they changed the R value of all of the studs in order to go backwards to calculate the HERS score rating, what the calculation was. And just by swapping out the studs, they were able to get a reduction of 4 to 7, depending upon the climate zone that the insulated version was being used in. That's a huge number to just swap out the stud and get -4 to -7 out just on getting that thermal break through the wall assembly. I'm not looking at my time, Brett, so you're gonna have to give me a hook at some point. So I tried to come up with some of the typical wall assemblies that are out there. The one on the top left is kind of that Larson truss view, used a lot in the West. I just did see a house in Colorado being built using them. It's a crazy technology. Their walls are, I think, 16 inches thick. Anyway, I'll just keep going. The one on the bottom is a conventional stud. There's I packed all this stuff in here so that if you grab the handout, you can cut and paste and use these in whatever presentation you want to. These were fun examples of wall assemblies that I have found along my way. Okay, this happens to be a house in Grand Rapids, Michigan. So this is Lisa Render's house, if I remember right. So the black, if you'll notice here, there is no OSB on the outside of this house. So what she did is she swapped out for this R10 insulation, rigid board insulation. Not that it met all the wind load, but it when you put in spray foam in that wall cavity, you got to have something to spray it up against. So she was not able to get our product in time, so she's irritated with me. Sorry. Anyway, so if you put 2 inches of spray foam in that wall cavity, you can get rid of the OSB on the outside in wind loads 1, 2, and 3. Wind loads 4 and 5, you end up having to put in 5 inches of spray foam. But this black product, that ended up being the same cost installed as the OSB. So big R value difference between 10 and 0.5 to be able to pull this off. She's got a beautiful house. So a good friend. Okay, this is another job done in Matt Reisinger sent me this the other day. This is a great house in Austin, Texas, and they got a complete thermal break through all of their headers. We went down there, Mark and I, and chatted with them for 4 or 5 hours of how to assemble this whole entire thing. And so they have a video coming out here pretty soon, but super high energy efficient. They were able to reduce the furnace size by 30,000 BTUs. Pretty much don't need one in San Antonio, Texas, but you do. But they reduced the air conditioning unit by 2 tons. So that paid for us and a whole lot more. So that's what you're doing this for. You get that thermal break in there and you increase the energy efficiency of this whole entire wall assembly. And I think I got a slide coming up that goes through all that. But you're starting to reduce. We have a series of houses, 12, I think, in Iowa, climate zone 5. And they used the foamed in product, and they did reduce the furnace by 30,000 BTUs and the air conditioner by 1 ton, and that paid for us again and then some. So extremely energy efficient. Another view, same one. On the right, I'm going to note, I love how they protected that tree. This is a remodel job where they were able to save the whole entire foundation and get a complete thermal break. I think they're 95.5% complete thermal break throughout this whole entire wall assembly. But they did protect that tree. My hat's off to them. This is a house in Canada. Sorry, Canada, I'm going to pick on you. This is typical up there if you want to increase the energy efficiency of your existing house. You tear all the cladding off, put on a rigid board insulation, then figure out how to nail on battens on here, and then put siding over the top and try to figure out where to get your rain screen in here. Quite complicated. It's a fun picture of the extent that people go to get that thermal bridge, break the thermal transfer. Typical insulation. Oh, this is, I was going to ding this out of here. Oh well. This shows the insulation, how much heat loss and stuff that you have in putting continuous insulation around the outside. I'll tell you what, if you can't use us, you have to put that thermal break on the outside. And you have to look at your modeling and decide if 1 inch is enough or 2 inches is better. Next, what is the thermal bridge? Solves the #1 nemesis in the entire construction industry. That's a fact. So it's a 6-in-1 solution. We'll tell you about that. 18% more energy efficient walls themselves. They're 3 times stronger than a typical 2x6. I'll start to go kind of quick here now. This is our our foamed in version being foamed in. We literally shoot a polyiso foam in and it rises from one end to the other. We have a continuous system coming up, but it still has that same truss. Looks like a mini bar joist out at the bottom. And our value of 19 plus. Next slide here. Okay, if you use our foamed in version for the top plate and bottom plate, okay, so a little education here. There's only 1% increase in energy efficiency if you use a thermally broken top plate and bottom plate. And I did not say that you reduced your energy bills by 1%, but that's the whole entire wall assembly. That's all it makes up in the entire wall assembly is 1%. And so I can't stand here unless you're net zero or a going for LEED certified or passive house to get the thermal break through the top and bottom. But it's it's my deal. I like it. I like the story. I like being 100% or 99.9. Okay, a house in Golden, Colorado. Super nice house. They also are doing 5 inches of polyiso foam in the walls, HFO blowing agent. On the right hand side, 2 photos. Those are pictures of their bump out windows where they got a thermal break through the top of it and the bottom. So they're in cold climate. So at least you can sit on that and not get a cold butt. They have on the left, they have a super tall energy heel on the top plate. So they actually had some leftover foamed in versions and they used them as a blocker to hold in all the insulation that they're going to put into the attic of this. I thought that was quite sexy. So the bare naked version without the foam, you see in the little in the middle there, 95.5 to 99 or 98% complete thermal break. We don't know what kind of foam you're going to use, if you're going to use any at all. These are made for Better World Builders was just on before, I think it was Mark, and they just did a project somewhere where they did dense packed cellulose at R3.5 per inch, and man, you can get a really high R value when you do that. Just like putting in better than an open cell foam. I'm not here trying to sell insulation, but the higher the R value, the better for that wall assembly. You got a whole lot of wall there. Okay, next. You're not trying to pull me off here, so I'm going to keep on talking, Brett. Okay, this is the house another house in Michigan. So the second line up, above grade walls, 31.9% energy saved just by using our foamed in studs. That's all they did. They used standard bat insulation in the wall. So another huge testament for us, or for any product, getting as far as that goes, getting a thermal break through the wall assembly. Okay, we're not always easy to use. You just got to do some thinking. On the left, you'll see a pre-built insulated header. I like that. We got LVL. It sits on top of our stud, but in some cases you have a triple LVL, and then you end up on the picture on the right, you just put in a little squash block in there in order to hold up that center header that sits in there. But window assemblies go together really fast. We have a number of houses, a couple hundred now built in the US, and we're already looking at shipping out of the country. Okay, more education. This is a typical modular, I shouldn't say typical, but this is one. I won't say where they're from, but they actually, in order to control cracking, they put in double studs throughout the whole entire structure. They do that because they glue on the sheathing and they glue on the drywall, and they want a wider flange. So they can actually use our product and save money, and they can get rid of half the studs in the whole entire structure. Okay, air changes per hour. I'm an advocate of sealing everything up and getting it as tight as you possibly can. So if you can build your wall assembly no matter what you do, and you can picture frame in the foam inside that wall assembly. I did this myself as fast as I could move that wand to spray foam in that to stop the air from being able to transfer from the inside. I literally went as fast as I could possibly go. And the picture on the left is actually our gap that we have in our bare naked version without the foam. That's how fast I filled that in. I just run the foam gun up one side and down the other to do that. But this is a little project I did in the backyard of my house. Energy efficiency. I left this in only because I can't stand steel structures. A huge heat loss. This is what you get. We can do this better. Everybody that's on this line, we can do this. We could do this. All these buildings way better than this in order to save energy. I'm tired of all the heating bills, just like everybody else is. Okay, 10 foot. You can read all this. I know I'm running out of time. I want to get to some other ones. You can read all this. This is another classic example of how not to do your wall assemblies and all the thermal transfer. I did pick those off the internet. Again, 56 degrees in this bottom right-hand photo. I heated it up to 120 degrees in order to force transfer through that wall, and it still stayed blue after 2 hours. Okay, Fourier's law. I'm an analytical. Mark can attest to that, Mark Willie. We literally take electric irons in order to force the transfer of heat through. And so again, this is a slide that's in here that you can look at, but Fourier's law calculations, don't go there. Fully code compliant. We use the Structural Building Components Association, smart people, in order to get our code compliance. Wind loads, we passed almost all the walls for wind load 5. So no matter where you're at, we're good. The foamed in version, we had to pass a E84 flame spread test. We actually did this at UL, and the flame only went 5.5 feet, and all the parties thought that they were going to just take our money. And they ended up coming out, all 16 of them. They said, "How'd you do that?" I said, "I got to go home and file one more patent." This is what we ended up doing. On the left was before the fire, and then after the fire, we still had 90% structural capacity left over after the fire. So we don't want the fire department to do anything different. They still got to put their scuba suits on when they go inside of a house that's been under fire. But on a 2x6 wall, if the wall assembly's been compromised for more than 10 minutes, the fire department cannot go in the house because the roof has the potential of coming down. Our walls are 20% quieter. So we've had a number of hotel motels reach out. When you unhook the ability of sound to transfer from one side to the other in 98% of the place, you can really get a quiet wall. Only 2 times staying in hotels, which I'm in a hotel again tonight. Only 2 times ever have I thought it was pretty funny to listen to what went on in that room next to me. Only twice. RC channels. Okay, when you go 24 inches on center, I think we're going to be talking about high energy efficiency and advanced framing. 24 inches on center. This is actually the whole onslaught of a 2,400 square foot house. This is all the fasteners you save. You didn't make the house any less strong. You made it stronger. And when you go 24 inches on center, the one good thing that you have for you, just spec out 1/2 inch high strength drywall. It doesn't cost very much more money. And the walls are just as rigid as back in the old days using 5/8 rock on those walls. I'm a journeyman sheetrock taper, so I kind of enjoy being able to frame at 24. The wall on the left is 24. I used to have a photo of 16 inches, so every 8 feet you lose 3 studs. All right. Here's, I put this in here, and I know I'm going to get done here in 2 seconds, Brett. So here's all the energy efficiencies of the top one is or the second one down is a 2x4 and then a 2x6. And then if this is the bare naked version of what we have, that's the overall, the middle column, that's the overall R value of just the stud, depending upon what you pack in for insulation into that gap, that cavity of our product. And on the right, that's the increase in energy efficiency of all the framing members then added up. And if you want this, Excel program, send me an email to brian@tstud.com. Probably don't want to give that out. Anyway, okay, field guides are all available online. You gonna cut me off, Brett?
No, I just had to laugh at that out loud.
Yeah, it's all good. Okay, so for all of you high energy efficiency people like Mark and I, we did pass all of our testing on the left for all the 7 1/4s. It was quite sexy to see how they break them all. I'm just floored. On the middle photo on the left is actually our first 9 1/4 that we tested. And on the right is our wood foundation product. This is some of the stuff that we have coming up here shortly. So that's what I got for you. So there's our phone number, contact info, the whole 9 yards. So I'm done. Okay. If Mark, you're still on, you can chat. That was fun to get through all in 30 minutes. I don't care what anybody says.
Brian, thank you.
Yeah, Brian, thanks for doing that. Thanks for joining us. This is the official networking session. We can stick around for about 35 more minutes. We kind of want to open it up and just kind of jump around in our conversation now. And for those of you who want to brave, are a little bit brave and have a working microphone, quite frankly, go ahead and raise your hand and I'll unmute you and we can, have a chat, get into the conversation. Otherwise, you can just throw your questions right in the chat box as you have been doing. Trying to find the question here. So I guess let me throw this one out to you, Brian, just to kind of, these are wood products, wood studs, and we have a huge increase, for what I've been told, in the cost of wood for our construction industry. In what ways does that impact, what you're doing? In what ways what you're doing, does it have an advantage? What are your thoughts there?
Well, the lumber pricing is obviously that's coming down. Not necessarily from the softwood tariff coming off, but for other reasons. Everybody doing puts and calls on lumber and forecasting, and obviously everybody being hunkered down from COVID, everybody working from home, they decided to do projects, and you go to big box stores and all they buy is hand select. They look down the board, twisted left and right. They all buy premium grade lumber. And so the price of that went, as high as I know, went $1,250 a thousand. And we were still able to buy our 2x3 and 2x4 that we use. We were still able to buy that for in the 400s. So we take the top of the tree. We don't take the main part of the tree. We take the top of the tree. So we've been able to be extremely cost conscious across the board. And I'm not sure that answered the exact question that you wanted to have answered, but that's pretty close.
Yeah, no, that makes sense. Where's the best place to source something like this? Can you talk about your sourcing?
Yep. So we have distribution in the United States now, set up through one company. We actually, from COVID, we are actually inbound from Canada. They closed that Canadian border when we had shops set up there, and they wanted me to quarantine in place every time I went up. And 5 of us, I got 5 other staff that have to go over and do training and whatnot. We just can't do that. That's, you got business to run. If we went over the border every other day, no big deal. So we're down here in Newton, Iowa, setting up shop. We're leasing in a very large facility here. and we're on the I-80 corridor and Highway 35 running north and south. So we have centralized distribution, and we have trucking figured out, and we'll be able to do job packs if that's what it is. We'll be able to get them on a truck, and we'll be able to get them to you. Just go to the sales@tstud.com and send us an email, and we'll figure out how to get your product. So we've been sold out, I know, but we're fixing that quickly. We thought we would have a pretty good smattering of people that like what we do. You know, we're a significant cost difference cheaper than putting rigid insulation on the outside. So we're the next best thing to making energy efficient structures. And being a certified energy auditor and running all the math, we have a lot of videos out there that help educate you on really what the upside benefit is for whoever you're building that house or building for. So,
what type of fasteners are used?
So that's interesting. When I ran the calculation of only 1% more energy efficiency to use the R19 product for the top plate. And when it was that, and I couldn't even tell people to go buy it, use it for your top plate. It's expensive. And so that got rid of almost all of the 4-inch nails. Otherwise, you had to use 4-inch nails. The bare naked, there's only a couple spots that you have to use them. And so just about everything now is a 3.5-inch nail gun.
Got it. How do you quote total cost difference between equivalent size and spacing of typical studs? And then they said something about taking out labor savings.
Okay, so I've been nice. I know the calculations on commercial. There's a construction means is an estimating software program, and that just about gobbles up most of the costs for us. Any labor savings, 24 inches on center versus 16 residential, nobody's giving up the difference because we're new, and they have to educate themselves on how to use us. So there's been no savings on the residential side. On the commercial side, though, in the modular, they can go fast. You start eliminating 25% of all your studs in a wall assembly, you can go quick. I've framed up by hand many 4-story, 5-story buildings, and if I could have saved 2-3 semi-loads of studs, man, I'd have been a happy camper. I'm the guy who started out, I know, in the late 70s. I was the guy who schlepped all that crap around, and so I had back surgery, sure. 25% less studs is a lot. That's 25% less places of thermal transfer. I get benefits all over the place. Look at all the nails you save. So it's good.
Not to mention the electrician, the rockers and the sheathers.
You're breaking up, Mark.
Not to mention the electricians, the drivers and the sheathers, the time savings for each of the trades that come in after the carpenters.
Yeah, there are savings for everybody. You know, in the modular home world, depending upon how that plant is built, if they're on the old chain system where you build this, you do this stage of drywall, or you start out with your framing, and then you get to wiring, and then you go to this and you go to that. Just because we allowed this center section to be able to be built faster doesn't mean that the next section got to go faster. So it's still the same time constraint as you go through, but a lot of the more modern ones, modular plants that are in operation and being built today, and the individual panelized wall builders, they go fast. They go really fast. It's a noticeable difference on how fast they go.
Great, thanks, Brian. You know, we got some different questions coming in. We've got some of our speakers still hanging out on the line. So if any of you have any specific questions for them too, we can just kind of have a larger conversation. We've got Dan. I don't know if you can unmute yourself. Dan with Edelman out of Rockwool. And I want to talk a little bit about, alternative exterior insulations. I think you guys talked a lot about that in the last in track 2. But, just some of the different alternative choices we have to rigid foam, both above grade and under the slab. Dan, I don't know if you can hear me right now, or if you want to chime in and unmute yourself and jump into this conversation. Looks like you're still, oh, there you are.
Hey, Brett, how are you?
Hey, good to hear you.
Good to hear you too. Yeah, so I'm Dan Edelman with Rockwell Insulation, just another foam-free product that's on the market right now. Been around since 1937, so definitely been ran through the ringer in terms of just longevity of these lower carbon products. And yeah, pretty much if anybody has any questions, just feel free to put them in the question box and I will definitely have time to answer them.
Thanks. So there is a question here. What about? I guess it's really just questions about blown-in Rockwell versus the bat. I don't know if that's anything you get involved in. The specific question is 3.5 inches of bat Rockwell insulation equivalent to blown-in.
So our bats are primarily, we have a very scientific way of putting the bats together in the factory. So the R value for the bats is going to be higher than the blow-in version. Our bat product is about 4.3 per inch when you're talking about our comfort bat product. And if you're looking at the blow-in, which right now we actually don't even offer a blow-in product, but I've known installation contractors that actually take our product through a cellulose machine and blow it in that way. But that way it's typically around a 3.8 to 4 per inch. So you're actually going to reduce R value. One of the things to note though, and especially my own home, I actually did the same thing. I blew in my own product, and knowing that it was going to be a reduction in R value, but I had a true 4-inch or 2x4 product in the wall, or 2x4 stud. So that being said, I understood that it was going to be a reduction in R value, but it was definitely well worth it. I also added continuous insulation. I used 2 inches, which now our Comfort Board 80 is now a 4.2 per inch. And that's a vapor open product, lower carbon than said XPS polyiso products. And I ended up basically just having a full, the one thing that I didn't want to do in a home built in 1874 was to start putting, vapor barriers in the wall assembly. So by doing that, it pretty much helped the carbon footprint of my own home, but also it really helped with the insulation value of it.
I was really intrigued to hear about the taking the cellulose, rig and pushing your product into that. Is that something you all? I mean, do you? I mean, besides bringing it up, do you provide any training on that? Is that something you not really recommend? You had mentioned it just reduces R value, which makes sense, but is that something you suggest folks to do if they're looking for an alternative to blown-in cellulose?
So because I am a spokesperson for Rockwell on this, I have to say that we do not recommend that. Because I'm a homeowner and I work with many builders around the country, I say that it works, but you do need to have a higher quality blowing unit, and it is going to degrade the conditions of that blowing unit far superior quicker than cellulose.
Got it. Thank you. Well, here's a question I'm just going to throw out there. Michael, Clement, maybe you have some thoughts on this, or if anyone else wants to chime in. But now that hemp effectively, I believe, is legalized in our country, and we're seeing a lot of interest in hemp insulations, hempcrete insulations. Is that anything you've seen before, Brian? Have you seen anyone use that, in between the studs at all?
I have not.
Okay.
I know Buzz Holtler is online, and I know that he's been following the hemp side of things a whole lot more than what I have. We've been engaged with a couple of different products that they wanted to do testing along with us, and so I can't mention them, but Buzz is pretty well up on that hemp side of thing.
Buzz, I just pulled you in. I don't know if you can unmute yourself and join us, or if you want to right now. You don't have to.
Hemp is interesting. I'm gonna say that. I think even Dan can say that hemp is going to be an interesting one for everybody to deal with on energy efficiency. They definitely are going to have a place. That's a fact. There's a number of companies working with that product. I know that.
Lots of good things to come with hemp products in the future.
This is Michael. Can you all hear me?
Yeah.
Great. So I'm really excited about hemp as a possibility. I mean, on the carbon impact of insulation scale, it's second only to straw bale in terms of its positive carbon impact. And rock wool is, I'm very surprised. It's actually on the better side of. I mean, it's still carbon impact is not necessarily where we want to see it, but it's really good. And the thing that's nice about rock wool is that its hydric performance is phenomenal. I mean, it's basically hydrophobic, so it can be used above grade, below grade. Can you say a little bit more about the use of that rock wool as a continuous insulation?
Where'd you go, Dan?
Rock wool, Dan person?
Yeah, I'm sorry. What was the question again? Using it as a continuous insulation?
Using it as continuous insulation, and in particular, using it below grade.
Oh, for below grade. Yeah, I mean, it's pretty much, you're putting it back into the earth where it came from. Now you'd still need a water membrane behind it, but pretty much use it just how you would with the normal foam product, but you're using rock wool. In terms of compressive strength, I know that's a question that always comes up. Primarily the soil and or concrete, if you're doing subslab, is going to be less than the compressive strength of the ComfortPort 80 product that we recommend for below grade.
And if you're using it as a below grade exterior insulation, Dan, and I of course love your idea of putting the water resistant barrier behind it, in other words, inward towards the center of the home. How do you find, have you done any testing on the degradation of the thermal performance once that rock wool becomes saturated with groundwater?
So we do have testing. I do have it available. One thing we found though, with the properly basically a French drain around the foundation or the footing, the water is going to, and during our testing, it's a 24-hour testing period. When we saturated the rock wool, it did not hold enough water for the test to actually be conclusive of how much loss of R value, because it drains so quickly.
Ah, good for you. That's a good problem to have.
It is.
Thank you, Dan.
Yeah, another question came in. Can rock wool be used in attics directly against the masonry chimneys?
If the question is mostly for heat, yes. The melting temperature is 2,150 degrees. At that point, it's going to melt. And if that area of your house is 2,150 degrees, I think you have bigger issues than what the insulation is going to be doing.
Yeah, that makes a lot of sense. Yeah, well, hey guys, I don't see any other questions right now. We're pretty much about 17 minutes before our time. I think we've been talking quite a bit here about insulation for the last several hours, 2.5 hours almost, more than that. Tomorrow, there's been, throughout the session, there's been some conversation, of course, about HVAC, heating, cooling, ventilation, water heating. It's certainly come up several times, unavoidable with some of the conversations we're having. But that's what we're going to be focusing on purely tomorrow: utilization. What are the technologies we're using to heat and cool our homes, our water? We've got a session about ventilation. We've got a multifamily LEED zero carbon tour happening as well. So we're going to get into a little bit of the multifamily side as well tomorrow. And then the next day, we're going to be talking about generation. So renewable energy, batteries, generating policy, generating change, generating equity. How can we do that to ensure everybody has access to net zero, low utility bills? So with that, and not seeing any other questions right now, and it's getting kind of late, let's go ahead and wrap up. Thank you all for joining us. Thanks to all of our speakers today. Big thanks to our planning partners again, Architectural Resource, Michigan Energy Efficiency Contractor Association, Michigan Geothermal Energy Association, and the Great Lakes Renewable Energy Association. Huge thanks to all of them. And we will catch you all tomorrow at 6 p.m. Eastern. Thanks so much.
Thanks, Brett. Thanks for your time.